Good evening. Thank you, Dr. Delaney. I am really delighted to be here as part of IEEE Oceanic Engineering Society to give a talk about the ocean technology in India. See, I'm just, the presentation flow is almost like this. That is, first I will just give some introduction, then some of the oceanographic institutes in India, then what are the technological areas of concentration, and then like observations, deep sea technologies, desalination, renewable energy, ocean structures, coastal engineering, acoustics, marine biotechnology, etc. And I'll just touch upon one of the forthcoming international conference that is going to take place at M.A.Atmanand. So I will be only giving a bird's eye view because the activities are so vast, it's not possible to go into detail in the next 20 minutes to half an hour. I'll just quickly go through. So India has got a very long sea coast because of basically of the islands here. It's of the order of 7,500 kilometers, and the exclusive economic zone may be even increased now, and India has put the claim for that, and then the land equivalent would be available in the ocean. I mean, that's how it is going to be. We have been given a ocean I should say, at this location. It's about 2,500 kilometers down south of the tip of India, the place called Kanyakumari, where we have been identified, we have been given an area of 150,000 square kilometers to mine manganese nodules. International Seabed Authority has given this, and we are in the process of developing the technology to mine these manganese nodules from this location. Now coming to basically the ocean technology in India, even though the space technology and the nuclear technology in India has really improved compared to what it was just after independence from the Britishers in 1947, the ocean technology had not developed that much. So our so to say the capability in ocean technology is much less compared to what it is in the space and the nuclear area. And there are other institutes who are working in this ocean technology, that is in the defense sector. So NIOT is the only institute which is working in the civilian sector. We have our sister institute for ocean information called INCOIS, and our another institute called National Center for Ocean and Antarctic Research, which works in the area of Antarctic research. I will be touching upon a little bit later on. Then we have the really oldest oceanographic institute in the country called National Institute of Oceanography. This has been there for from 1960 onwards. Then we have the Marine Wing of Geological Survey of India. Then about the Earth Sciences part, we have the institute called ENSES from Trivandrum, and also on the biological side we have an institute called CMLRE here. And for the marine area management, we have an institute called Integrated Coastal and Marine Area Management. It is situated in the same campus, and I happen to hold charge of that institute also. It's a small institute basically. NIOT was born here in this place in the institute called Indian Institute of Technology at Madras at Chennai, and when we grew in the year 2000, we had to move to a new campus like this, and these are the major aims for our institute. So this is the campus which now we are overgrown, and we are in the process of going into another campus which is a seafront facility, and one of my intentions to visit here is to see how Scripps is. Our intention is that we should be like Scripps or Woodsole or Ifremer or Jamstack with a seafront, with a pier and things like that. Now coming to the overall activities at a glance, we work in energy and freshwater. On offshore structures we work, on deep sea technologies. I will go to a little bit detail a few minutes later. We have a good work on ocean observations, acoustics, coastal and environmental engineering, and we are developing lot of marine sensor systems. We work on ocean electronics to develop various subsystems. We work on marine biotechnology, carbon dioxide sequestration, and gas hydrates, and we also have 4 ships which are going at various locations in the Indian and international waters. Now I will just touch upon the ocean observation systems. We have the buoy program. You can see that these are some of the buoys which are there in these locations. These buoys measure various subsystem subsea temperatures using acoustic Doppler velocimeter. It measures the current, salinity, lot of parameters. Similarly, the data above, that is the wind speed, wind direction, solar radiation, humidity, all these are measured, and this data comes to through satellite to our center here, and M.A.Atmanand is located somewhere at this point. It comes there. So these are some of the pictures of the buoy after deployment, and this is a calibration validation buoy. That is when you have the satellite measurements, in order to calibrate or validate the data, we require a special buoy, and this is that buoy. And we also have you know that in 2004 we had a major tsunami. After that we have got a program where we put buoys in this location where the Andaman ridge is there. This location we put lot of buoys for measuring the water level changes in case of an underwater seismic event takes place. Also we have a similar buoy like this in this location, this Makran coast. Here also there is a fault which can cause tsunami. And we also have developed the bottom pressure recorder indigenously, and this is some of that sea trial of that going on. I just want to give you some data. We had various cyclones, one cyclone called Helen. This is the path of the cyclone, and we could get valuable data from our buoys, and because of which our weather prediction system in India has really improved compared to what it was much earlier. Similarly, for another cyclone called Leher also, it was tracked, and you can see some of the data, how the sea surface temperature comes down, how the air temperature comes down, air pressure comes down. All these data is available from these buoys, and this has gone to the models, to the Indian Meteorological Department, who could really use this for prediction of the weather. And very important in this was the Phylline cyclone. It started from near this islands of Andamans and moved on, and we had the data from all these buoys. You can see that the air pressure comes down, wind speed increases, all these things, and the Indian Meteorological Department could predict accurately in terms of time and space where the cyclone will hit. And the local administration was so effective that they moved all the people, and I am really happy to inform that you can see this here. Not a single death was there due to cyclone, but of course there is a associated thing. There were some deaths, but due to cyclone per se there were no deaths. So we are very happy that we could be at the somewhere at the background, because these things are not known outside, because only the IMD predicts and the people are moved, etc. So, but some of the news reports, we were quite happy that it was well appreciated by the media. Media normally, of course, I am not sure about here, but media normally goes in the negative propaganda only. They don't say that if the prediction was not good, they would have put all the blame on all the systems and that it didn't work, and I mean many things. So that way we were quite happy with that. We also have rainfall data. I mean rainfall in the ocean is another parameter which is very important, which is normally not available. Now coming to the tsunami part. We have the bottom pressure recorder which measures the water level. It just measures every hour and sends it acoustically, and through satellite it comes to our M.A.Atmanand. And in case of underwater seismic event, the sampling increases and you get more data, and it comes through satellite, and we can see some of the data. In September 2012 we had an undersea earthquake, how the data was obtained. This is how it works. All the data that is coming from the tsunami buoy through satellite, it comes to us through a service provider to M.A.Atmanand as well as to our sister institute. The sister institute has got data from various other locations also, other buoys from other countries also, Indian Ocean rim countries, and they are the people authorized to give a warning as to whether there will be a tsunami or not. Within 7 minutes of an earthquake, the information will be available whether in the net, whether it would cause a tsunami or not. And I am happy to inform that India has been now given the status of regional tsunami warning system, and we are giving the tsunami warning to the Indian Ocean rim countries like Pakistan, Sri Lanka, Philippines, etc. And we don't have to depend on the, earlier we used to depend on the Japanese tsunami warning center, but we don't have to do that now. But another new aspect which we are working on is, there is a hypothesis that there is a relationship between the Arctic system as well as the Indian monsoon. So this tele-link, to establish that, India is now has got an observer status in the Arctic region. So we are going to put a Arctic mooring, something like this, which has got CTDs and various other ADCPs which are looking upwards and downwards, and this would be put in this location, that is Kongsbergen Fjord, in this location in this July, and this would be in this condition below the ice. It will not have a direct live data transmission. It will be kept there, and after a year this will be taken and all the data could be utilized. So this is one of the first things which we are going to do in the Arctic. Of course, Antarctica, we have got, India has got 2 stations. One is old station called Maitri, and another one, a new one called Bharati. It is already there, but in Arctic this is the first time we are going to do, and it is named as Himadri, that is it is called ice, so to say, you can say. We have something similar to Argo. We have developed buoys which go into the sea with a variable buoyancy engine, and we are transferred to the industry, and this is the one of the tracks of one of these buoys which has been indigenously developed by the Indian industry. Similarly, we also have a coastal drifter with a microstar drogue in this form, and this has been tested at various locations and following the DBCP guidelines, and it has measured the mixed layer surface current, and we had some of publications out of this. So this is also one important work which we are doing. We are now in the process of transferring the technology of this to the industry, so that industry can manufacture this in large numbers. We also established a high frequency radar setup. Of course, in the US it is completely covered, I was told, in all the coast, but in India we have covered only the east coast and a small portion of the west coast. These measure the currents up to a distance about 200 kilometers, and this is the data which we had during the cyclone formation, which I just explained earlier, that is Phylline cyclone, and this is the place called Port Blair in the Andaman Islands, and we have a transmitter here and receiver in another island called Hut Bay, and this formation could be exactly found here. Similarly, when this reached the mainland, there also we had a similar HF radar system, and there we compared the HF radar data with a buoy data, and we could see a very good correlation. But unfortunately, what happens is that when the cyclone was so furious, after it hit the coast, the antenna, I think I am seeing one antenna here, I mean something similar outside here, the same HF radar. That antenna broke, and finally we could not get the data after the hit of the cyclone. So that is one problem, but I think we will have to do something on that. We work on ocean acoustics. We measure a lot of shallow water ambient noise, and you can see some of the seabed characterization from noise measurements we have done. We put vertical arrays and measure the reflection loss, and we can see the measurement in one location called Kadalur. Similarly, multi-beam backscatter data, I mean you can see this here in the place called Goa. Some of the texture, seabed grain size texture evaluation has been done. This is the picture of that in the in the ocean. Now I will just move on to deep sea technologies. In the deep sea technologies, one of the main aim is to construct a crawler which can go on the seabed to mine manganese nodules, because India is a signatory in the International Seabed Authority, and we have to develop the technology to mine these manganese nodules from the deep sea. So in order to do that, we have to measure the seabed property in situ, because seabed property, if you take it out and measure, it changes bearing strength and shear strength. So we have developed an in situ soil tester and tested at 6,000 meters. We also developed a world-class remotely operable vehicle which has been tested at 6,000 meters. Another area we are working on a wireline coring system, that is for gas hydrates. I will just come to that in a few minutes. For all these things, we don't go into developing up to the sensor level. We do only integration of this into subsystems and encapsulating and using it. So we don't have a, like for example, a system wherein we develop each of these instruments or acoustic communication system, etc., except in some acoustic transducer, which I will explain a little bit later. So many of these things are on the system level. So to mine these manganese nodules, a crawler like this was originally developed, and we mined sand at a depth of 500 meters. And this concept of flexible riser, wherein you pump the seabed material through a flexible hose to the ship, is to be used ultimately to mine manganese nodules at a depth of 6,000 meters, wherein we have this crawler which moves on the seabed. It is something like this. This is something like a potato harvesting machine which will pick up these nodules, and it will put into a crusher here, and it will crush it, and there is a positive displacement pump which pumps it to the ship, and a cable from the ship takes the complete weight, the outer armor, inside power at 3000 volts, and deep inside fiber optics for all communication. So this is operated, of course, using a computer and a suite of transducers and final control elements, and the final drives are all due to hydraulic system. So these are some of the specifications of the whole machine which ultimately we will be going to make in the near future. Some of the tests in between, what we did was, we had to test this picking up device and crusher, etc. So what we did was, we don't have we cannot go to the 6,000 meter immediately. So what we did is, we did a test at 500 meters, but 500 meters we don't have nodules. So what we did is, we made nodules of the same property as that of the deep sea, with the same shore strength, shore hardness, and buoyancy, etc. And we put it in the sea in some location with effective positioning using dynamic positioning vessel. Then we launched this crawler system, you can see that, and it picked up and crushed it and sent it to the ship. These are some of the pictures of that. And we also had an acoustic positioning system at that point in time. So this is how we are, this is one level of testing what we have done before going to the 6,000 meters. And I told you that we have to measure the seabed property, for which we have developed a in situ soil tester in this form, which will sit on the seabed, and these are some of the specifications, and we measure the bearing strength and shear strength and transmit it online to the ship. You can see that this is the nodule bed, the picture taken from the soil tester. This is the cone which has gone into the seabed, and the measurement would have taken place, and this is the shear strength and the bearing strength which is measured online. So this is a depth of 5,269, if I remember correctly. The other one which we have developed is the remotely operable vehicle, which is connected to a tether management system through an umbilical, and it is launched from our ship called Sagar Nidhi. It is a DP vessel through a side launching, and these are some of the subsystems in the ship, storage, winch, launching retrieval system, etc. And this is a picture of that launching which is being done from the ship. And this has got two manipulators. It has a 5 function and a 7 function manipulator. It is fully hydraulically operated. And you have got, this is the tether management system, this is the winch which contains the spool of tether, and these are the specifications, the navigation system with the fins and other systems. It goes at 6.6 kilovolts. So the power from the ship is converted to 6.6 kilovolts, and we have got a drive mechanism, and it is done at a higher frequency, because at higher frequency the size of the transformers would be much less for the same power rating. So what we do is we transmit this power through the storage winch, and it comes to the tether management system, where we have got a transformer to take this power, convert it into DC. Similarly, there is again a power pack here in the ROV which converts it into DC, and it is used at 24 volts, 300 volts, etc. for the various subsystems. So this is a bit complicated system, because controlling, working at high voltage and high frequency in this system is a lot of protections, and many issues are there. There is, as you know, when the switching is taking place, EMI is there. So EMI, we had problem with camera. So many issues were there which we sorted out systematically. And this is how the electronics and instrumentation is there. All the suite of transducers are connected to a standard compact field point module of NI, National Instruments. So that's why I said we all do in the system level. We don't again have a complete data access system made exclusively for this. We used already available systems, and this goes to the ship, and ship we have got something called again a system of NI which takes all the data through this fiber optic, and it is used for display purpose. And these are some of the parameters which are measured for the ROV. One important work which we did is in the Rodrigues triple junction. That location is this picture is not very clear. This is Chennai in India, and this is the location of Rodrigues triple junction, where India has put a claim for hydrothermal sulfides. So this location is called Rodrigues triple junction, and our ROV had gone there to see of the underwater volcano or things like that, but we could not unfortunately see underwater live volcanoes, but only the basalt rocks, etc. I'll show a better picture in the next slide. The important factor achievement in this case is that using camera we saw all these things, and my team was on board the vessel Sagar Nidhi, about more than 4,000 kilometers away from India, and through satellite I could sit in NIOT and see that the actual pictures that is there. So this we did for the first time, and it was a good thing that we could really see what is happening online. Of course, this is I have seen this. I think Japan has done this with their manned submersible also, but for India this is the first time that we have done it. These are some of the underwater pictures which we have taken, some of the organisms which could be seen, and this is the basalt rock. It is all formed maybe thousands, millions of years ago, and is at 2,823 meters. We could also take a core of a manganese nodule. When it was put, we took a core sample. We could get 2 nodules at Central Indian Ocean Basin, and some of the water sampling. And there is a site in the Bay of Bengal in the east coast of India, where it is said that there are some indications of gas hydrates through BSR, that is bottom seismic reflectometer. So we went to that site. We could just see some of the organisms. We could not, our sniffer, we had a methane sniffer. Unfortunately, that did not sniff any methane, but we could see some of the organisms which they say, I am not quite sure about this, that these organisms are an indication that in the near vicinity there is gas hydrates. Now for the gas hydrates, with a US company called Williamson Associates in Seattle, we are developing a coring system like this. That is, this would sit on the seabed, and up to a depth of 2000 meters it can be there, and it can drill up to a depth of 100 meters and take core samples in the form of magazines and bring it to the ship with under the same pressure and temperature. So this is a very good instrument, because otherwise we have to use either George Resolution, which is a drill ship of US, or Chikyu of Japan, which will cost per day multiple hundreds of thousands of dollars. So it's very expensive. So this can be launched from our normal ship, and we could do the trial. But we had some issues in this. This has not completed the sea trials. It is in India, and we hope that soon we will be doing a core sampling in that location. We are developing another ROV for 500 meters. It is undergoing some trials in our acoustic test facility. Actually, this ROV is a small one for 500 meters. It can be used anywhere, but our intention is to use this in the polar regions. That's why it's called Polar ROV. And our intention is to drill ice cores from the bottom of the icebergs. So as I understand that that ice cores would be there for millions of years, and this measurement there would really give a lot of indications of many things. I mean, I'm not a expert in this paleoclimatology. I think the people who are working in that, they say that gives lot of information, and that's why we are in the process of making it, and hopefully we should be taking it this July to that location. Now coming to the energy and fresh water from the sea, we were earlier working in the wave energy, wherein this is the simple concept. Wave energy comes and there is a caisson which air moves up and down, the turbine rotates, and the energy is, this is a very simple concept. But what we found was that we had a plant here in a place called Viziñam near Trivandrum, that is in the southwest of India. But we had lot of experiments done, and India being close to the equator, the wave potentials are quite low. So we decided not to pursue further in this area of research, but we have developed something called a backward bent ducted buoy, the same concept, but this would be floating in water, and air will enter here, and water will enter here, and the air will be pushed out through this orifice, and we will put a turbine there, and lot of experiments have been done using this in the field. One another area which we are working is, we started with ocean thermal energy conversion, but we had some issues and we could not proceed further, but we slightly sidetracked from that. What we did is, the water from the surface of the ocean we took and put it in a chamber and evacuated it. So water boils at room temperature, and that steam is condensed using the cold deep sea water, and we get fresh water. So this concept has been successfully utilized in places of islands in India called Lakshadweep. You can see that pipe is laid like this up to a depth of say around 800 meters, and this is the plant, and this is the picture taken from the helicopter, because that region you don't have a lot of flights and things like that. So this is you can see this is the sump, and this is the plant building. I'll show some other pictures also. I think I don't have more pictures, so I will just explain here that these islands have got a so to say, its feature is such that we get a depth of about 1 kilometer very close to the coast. So this is very economically viable in those locations, and the people there are really starving for water, and this has been a very good solution for the people in the islands. The same concept of temperature difference is used in the power plant. The power plant, the lot of waste heat is after cooling is left to the ocean. So that has got environmental issues. So what we do is we replace that cooling tower. Cooling tower after all consumes a lot of power. But what we do is we take that surface seawater, which is the so-called, we take the hot water, again boil it and use the surface seawater and cool it, and using the same concept we again generate fresh water. So similarly this particular thing has been done in a place called Ennur, and we are generating fresh water in this, and one more power plant we are going to establish this plant. And you can see some of the experiments which we did and a lot of optimization, all those things we have been doing. A slightly different concept is used using solar power. Instead of low temperature thermal desalination, we used multi-effect distillation. Multi-effect distillation plant is a very common one, basically used in all Gulf countries. Only thing is we put solar panels like this, and here we have the seawater, and the heat concentrates here and water boils, and it goes to this MED system, and we get fresh water. Only thing is in the night this cannot function. So what we have done is there is another boiler here with a lot of shrubs are there in that location. Using the shrubs you can fire the boiler, and night you can use that heat also. So it's a combination which is working in a place southeast of India. I'll come to some of the ocean structures and how we have some protection system in India which we did. This place is Pondicherry. It was a French colony, unlike the other portions of India which were all British colony. If you have not visited, I think you should come. It's a very beautiful place. But unfortunately what happened is that this coast here got lot of erosion, and the beach was lost completely. So the local authorities approached NIOT, and we gave immediately a simple solution of sand bypassing, and it was done, and we got about 60 meters of beach came up, and they were quite happy, and they want to do the whole coast. So we are doing a lot of instrumentation has been done, and we are putting it into models, and most probably we will be putting some submerged dikes in this location to grow the beach. You know, in India we have got two types of monsoons. One is southwest and another northeast, and a lot of sediment transport takes place in these locations. And even though we do lot of observations and modeling, still finally how it comes is still a question mark. So we have to really do a very careful job in this case. In another location also in this place, we are going to do a similar concept like this, geotubes, that is submerged dikes. And these are some of the work which we did to find out whether it will do overturning, how much of weight is there, pressure, all calculations etc. has been done, and modeling has been done, and you can see that this is how the submerged dike will be there and how the beach will grow. We have another project wherein, you know, this location in India, this is the place called Gujarat. Perhaps some of you may know that this is the place from where our new Prime Minister is coming from, and he had an idea, bright idea of constructing a dam here, and there are twofold interests of that. One is that once you construct a dam in the catchment area, a lot of rivers are discharging fresh water. So this region will become a fresh water in about 5 to 10 years, and lot of industries and lot of developments is possible in this region. Second thing is that the distance between these two towns here, normally it will be, you have to travel all the way like this, about 500 kilometers, it could just be reduced. So the construction of the dam, NIOT has been given a task of instrumenting all these regions, because a lot of tidal variations, about 10 to 15 meters tidal variations are here, and currents are quite high. So we have instrumented this, and a lot of modeling work has been done, and we are in the process of giving the dam alignment. Of course, after all these things, the construction per se is a multiple $1,000 project. I don't know how they will be doing it, but these are some of the results of the observations and some of the data which is going into the model. We also have on ocean structures, as I told you, this is a structure of a sump in the island desalination. We have instrumented it with a lot of pressure transducers, And what we have done is that we have put wave rider buoys at various locations where the wave approaches, and we have modeled how much pressure variation is coming here, which has been validated by the measurements that is there in these locations, because of which we are able to now standardize the construction of this type of ocean structures. So this is another area which we have worked on, and some of the movement of the sump, how much of dead weight is there, how the movement is there, all those things are also been impulse loading tests also have been done in this location. We are working in the area of offshore wind. So to start with this offshore wind, we have to put a structure for measurement of wind using LIDAR. That is the collection platform. We have just designed it in a location called Rameshwaram and Kanyakumari. This is the southernmost part of India, these two, and another location also in the place of Gujarat. So these two we are doing, lot of analysis has been done, and we will be soon putting up these platforms. Next area which we are working on is an offshore numerical tank, wherein there will be a normal tank which will generate the waves. We also will have a computational facility where all the requisite softwares will be running, and any problem that is there could be analyzed there, and lot of visualization would be possible in this form, and also finally the actual model also could be tested. So this offshore numerical tank is another new facility which we are going to set up in NIOT. Marine biotechnology is an area which is linked to NIOT in some form. So one important thing where we did is, you know that this type of any device that is put in the sea, it will collect smaller organisms, and to eat that larger fish will come. So we have put this fish aggregating device, and this has been a great success in the islands of India, wherein the people, the island population is fully after NIOT. We have told them how to make it, how to deploy it, etc., so that they will get lot of fish. So this is one of them. Similarly, another one is for the protection of the coast in a place called Orissa in the northeast of India. We have these type of structures. These type of structures are put in the shallow waters, which will prevent the erosion in these locations. Another aspect is that lot of growth will be there. To eat that, the fish will come, and the fishermen can just have the fish catch without going to the deep sea. So this also is quite successful, and you can see that this whole India, we do lot of things using sheer manpower. You can see how these are being deployed by the fishermen themselves. They have just taken the challenge, and they themselves have done this work under our supervision. We are also working on algal biotechnology, that is for biofuel and nutraceutical. We have done lot of experiments in the laboratory condition. We are in the process of taking it into larger scale, and biofuel alone will not be an economic proposition. So we are also getting lutein. Lutein is a very expensive biological it is used for various cosmetics and various other applications, so it's quite expensive. So that and oil together would be an economic proposition. Also, we are getting lot of samples from the deep sea, and the deep sea microbes which are being taken at the from the deep sea are taken into this deep sea high pressure serial fermenter system, wherein they are again put under the pressure and low temperature, and lot of experiments are done in under high pressure, and we have got lot of isolates which have got good potential for cancer, to fight against cancer, etc. But of course this drug is a very long proposition, it will take a long time for any success to come. So these are some of the things where pigments also are produced using various types of deep sea microbes. This is another successful area where we have 9-meter diameter cages which are moved in the deep sea, and we grow various types of fish in this under controlled conditions of feed, and within a few months they grow up to sizes of about 600 grams or so, and the fishermen are quite happy to harvest them. This is we are transferring to the local fishermen so that they can really make money out of this, and this is another societal program which we are working on. We work on also ocean sequestration, that is carbon dioxide is we plan to sequester on the steel slag, and steel slag will have carbon, and when it is put in the coastal area, that will also prevent from erosion, and also a lot of growth will be there and fish will be aggregating there. So this is the area which we are working. We have done a lot of experiments. We have got a pressure chamber, etc. There we do a lot of experiment to see how much of sequestration is possible for a given quantity of slag. These are some of the ships which we have. Sagar Nidhi during its southern ocean expedition, and Sagar Manjusha is a slightly smaller one. Sagar Purvi and Pasmi are very small coastal research vessels, and this Sagar Nidhi was used for ocean thermal energy conversion. Now it is decommissioned. These are some of the test facilities which we have. We have an acoustic test facility where we calibrate transducers, acoustic transducers at various frequencies. We have a hyperbaric chamber up to, we can test up to pressure of 900 bar, that is 9,000 meters of water. It is 1 meter in diameter and 3 meters long. And we have a sort of a pond here, test pond, where we can test the underwater crawler and all other systems which has got especially acoustic transducers in that. So this is also in our campus. Our sister institute, we don't work on AUV, sister institutes work in that. This is the one AUV developed by our sister institute called National Institute of Oceanography. This is the one developed by Central Mechanical Engineering Research Institute. What we are going to work on future is we want to put man at the depth of 6,000 meters before our space people put man on moon. So this is our target. So we are in the process of identifying some partners to work together with M.A.Atmanand. And next one is on a 10 million liters per day desalination floating plant, where the same concept which I explained earlier will be used, and the plant will be floating with a 1 kilometer long pipe and will generate fresh water. And of course these are the other smaller things, AUV also we want to get in, and drifters, gliders, etc. Before concluding, I just want to indicate that in M.A.Atmanand we are going to have with IEEE OES and India and IEEE OES Japan, this is called the UT, Underwater Technology Conference, in the year 2015. It is from 23rd to 25th February, and that is the most pleasant time to visit India. Otherwise you have got only hot, hotter, hottest, so you will not be able to stand that. So this is a very pleasant period, and the time is there to submit the abstracts. And this is you can visit India if you are not visited, and there are lot of like Mahabalipuram in the south, and still Kanyakumari in the south, in the north in Delhi, Agra, Taj Mahal in Goa. I mean, there are so many places which you can visit comfortably during that particular period. So I would all invite you to, urge you to put up papers for this, so that more participation is there. And IEEE OES would be definitely taking an active part in this. I had invited our director also, and she said that she will give me a confirmation soon whether she will come or not, and I hope many of you will participate in this. I will just give a small brochure. I have exhausted, so I will just leave. I got only one of them. I will just leave it, and it is available in the website. This is taken from the website. So if you go to our M.A.Atmanand website, you can easily find out. If you go to this M.A.Atmanand website, you can easily find out this website. So I would invite all of you to visit India. So I would really like to thank Dr. Delaney and the director of Scripps and for giving me an opportunity to come here and talk before you. And I would also thank all of you for having come here at this time and for a patient listening. Thank you very much. You have any clarifications or anything, I would be happy to. Yes, please.
Thank you for a very interesting presentation. We don't have so many opportunities to hear such rich kind of research and what to do in India. And my question is you expanded so much, and I understand the area is for which you get your data is like 5 times the size of California. I read somewhere. There must be a lot of data coming. How will you handle, how you store the data, and what to do with the data? With today's technology, and everybody is talking like big data and fast processors and fast access to the data and mining the new information from the data which not necessarily you think are related. Is there any activity in that direction?
Yes, thank you for this question. This data which is landing in NIOT is immediately mirrored to our sister institute called Indian National Center for Ocean Information System. This institute is the custodian of all the ocean data in India, and that institute has got all the facilities, high performance computing system, etc. to store everything, and they also have a backup mechanism wherein in case, God forbid, in case anything happens there, they will be having in another location in India also all the data mirrored, and the data that is available there is available for the researchers without any payment. For anybody it is available, but only thing is that you have to give a sort of undertaking that it is to be used only for research purpose. It can be done through their website, and a username and password will be given, and it could be really used. There is no issue. But if it is for a commercial purpose, it's not so. There will be some cost factor involved with that, but otherwise it's available for the public, not even for Indians. What I am trying to tell is that it's available for anybody, and many of this data is going to the common this thing that is NDBC site. All these things, for example, our boy data is all going, they are all got numbered as per that NDBC. You have got some standards are there. It is numbered as per that, and it is possible to be, taken from that site. So it is very, very done in a very transparent manner. Yes.
I have 2 questions. One is, it was interesting to hear that you're talking about a floating desalination plant. And I'm wondering what other floating infrastructure you're working on. I think you said this would be a mile offshore, whether you're looking at floating ports or floating power plants or anything else. And the other question I would have is, you're talking about harvesting manganese nodules at 6,000 meters, and how you are looking at environmental protection at the same time, because I think one of the concerns is that it will destroy a lot of the sea bottom, the benthic layer, as it's harvesting. So I'm just curious how you balance environmental protection with economic production.
Coming to the first question, we are in the process of having a sort of spar floating platform for our desalination plant. It would be somewhere offshore. It will be about 40 to 50 kilometers away from the shore. It's quite far. So, you may also ask the question, if you generate water, how do you bring it here? That's all some questions which we ourselves have to really answer, how to do it. We cannot lay a pipe, because cost of water is not like cost of oil. If it is so, we could have done it, but not so. So we are working in the spar, and we are working with an industry to have a detailed project report on the complete 10 million liters per day floating platform. So that's the area which we are working on. Coming to the manganese nodule, the environmental impact assessment has been done by our sister institute, National Institute of Oceanography, in various methods. They have followed and done that. In our method, what we are doing is it's like a potato harvesting machine. It will just pick up, because these nodules are not buried deep in the ocean. It is just lying on the bed. 25% is slightly embedded, 75% is above the bed. So these nodules are picked up with minimum of intervention of the benthic organisms or whatever is there in that location. Of course, we have to still work on this, because it is a very long way to go for ultimately mining of this manganese nodule. So many aspects, what you said, we have to still further address before embarking on this, because International Seabed Authority till now has not given anybody any license to mine manganese nodules from the deep sea. Of course, in the Cook Islands and other places, it is in the very shallow region, and also placer minerals are almost in the coast, which is in the exclusive economic zone of that country, and the International Seabed Authority does not have any role in that. Only that country's the state has to take care of that. But in the deep sea, definitely there are much more precautions to be taken before embarking on a commercial basis, this manganese nodule mining. Yes.
Two questions with a follow-up on the manganese nodule question. Presumably it's a very energy-intensive process to suck up the manganese nodules to the mothership, and it is not very clear from that diagram, but I assume that you make sure that you only suck up manganese nodules and not too much of the sediment, because is that true?
No, that's right. When you pick up, what happens is that the mechanism, actually it is not sucking, it is picking, because sucking means it will suck everything from the nearby. So it is just picking up, and the mechanism is such that any other thing which is not the nodule will just fall there itself. The mechanism. Sorry?
Is there some sort of sieve?
Yes, it is like a, see, it is like a, I don't know, you may know there is something for cutting the hair, no, using an electrical machine, no? I mean that battery operated one, not like the shaver, but the other one. You would have seen that it does like this. Something similar to that is the one which just picks it up. It picks it up, and then the nodule only comes, and the remaining will just get there. That is why we went to this particular technology, because if you go to the patent, I think US patent itself, if you see to the website, there are at least about 500 patents on picking up, how to pick up these nodules, and they are all various types which have got if you pick up the whole thing, it will suck all the environmental things, and that is why we don't want to do such type of things, and this is supposed to be the minimal intervention one. So that is what, and power, if you see for our thing of 8 ton per hour, it is of the order of about a megawatt, but the economics of this is depends upon the price of metals. The cobalt and nickel are for India most strategic. So we have calculated IRR, that is investment on rate of return, or IRR, that is coming to about 15%. So anything more than 10% is supposed to be economically viable. So that's what we are working on.
And my second question is, you showed an amazing photograph of the Stone Age field near the Rotterdam Circle Junction of the ROV, and you've been there to Chennai. I'm just wondering about the temperature rating of those arms which you use to manipulate near the hydrothermal field. Probably you didn't go to an active hydrothermal field, but what is the temperature rating?
No, the temperature would be order of 250 degrees centigrade, and they will be spewing out acids. So it is a problem. You cannot directly go there, and the temperature gradient is very high. Yeah, that temperature 250 will be only at just at the point where it comes out. Immediately, because there is a whole volume of seawater at a temperature of about 1 or 2 degrees centigrade. So the manipulator has to be very careful. Only if you have to go and take some sample from that location, we have to be very careful. So this manipulator, what we have done, it is not designed for that temperature, no. And even there are some worms which can have a differential temperature. Perhaps you would have known that. I mean, its body, one side would be at 200 degrees and the other side would be 1 degree, and still nothing will happen to it. I mean, that is how it works. Yes.
Just a quick question. You mentioned that you are using some acoustic devices to record acoustic data
Yes.
on the sea. I'm wondering what is the application of this data you're collecting?
This application is, I mean, lot of applications. One is about the marine mammals. Like we get the whale whistling, then there are some many other mammals. Yes, yes. I mean, like what they call it as, I think, the jackhammer. I mean, I had. Yes, I mean, because I am not with the biology background, so I mean, many things are there which, I mean, if the detailed presentation I can show all those things, recordings are there. That is one. Second thing is on any other vessels which are passing through that, we can get the propeller noise, and that could be recorded. Second thing is basically on the rain noise. Rain noise which is due to rain what is falling in that location. We will be able to do a lot of analysis of that rain noise and find out the droplet size and how much is the quantity and many things, instead of having a conventional sort of rain gauge where water falls and the tripping bucket mechanism and all those things. So some sort of correlation we are trying to establish for rain. So these are some of the what to say, civilian applications, because we are not going into any naval application. Naval, I mean, I think I don't have to tell, there are so many things, but we are not into that.
Oh, thanks.
Okay. And there's an array, basically it's an array, so it just sweeps some region.
So you have, for example, if you have one sensor at one location, or you need to have like multiple sensors to come up with some kind of...
No. It is only, there is an array, a vertical array, which is just put, and then it measures all that region it measures. Yes.
Professor, can you talk about what kind of maybe educational relationships the Institute has with universities to grow the next
Yes.
generation of research?
Yes. What we have is with two universities. One is the Indian Institute of Technology at, I mean, Madras is the old name for Chennai, so they still retain the name Madras. And Anna University, again, it is in Chennai. These two institutes, we have got a program wherein in Indian Institute of Technology, we are sponsoring a master's program wherein 10 candidates are sponsored by M.A.Atmanand, and those students will work for projects which are related to M.A.Atmanand activities every year. And similarly in Anna University also with various departments, Department of Mining, Department of I think Electrical Engineering, we have collaboration wherein students could work. And apart from that, we have something called in India, there is something called Senior Research Fellow. For example, a student is registered for PhD. He can work in M.A.Atmanand and he will get a slightly more, so to say, the scholarship. And he can work in a problem which is of interest to both M.A.Atmanand and the student, and then he could get a degree also. So that way we are developing lot of these things. And then we also have a master student in any other university. Suppose he wants to do do his project in M.A.Atmanand, he can online get into fill up the forms, etc., and he can do that in M.A.Atmanand. Also we do internships. Internships we are slightly restricting because India is not like US. The number of students are so large, so we get many numbers. So internships we are somewhat restricting, but otherwise masters and PhD, no problems. Okay. Yes.
You talked about creating indigenous technology. Could you also talk about how you create relationships with technology companies in the United States and other countries? Because I I'm curious, when you're trying to create new technology, I mean, surface vessels or acoustics, there are many companies, Norway, United States, other countries, that have some of those technologies. So are you trying to avoid using them, or are you trying to find partners? You could talk a little about the philosophy of technology development, if you might.
In many of our systems, we don't say that we want technology from here, there, or anything like that, because we have a mechanism wherein we have to give equal opportunity for everybody in the world. So we cannot choose anybody. That's very difficult because we are funded by the state. The rules are very strict. So we have to go by tender, that is through public tender, through internet. We have to put that, and even the means of putting the tender, I think you are familiar with that. It is all through electronic means. You cannot do anything. Everything is electronic, so nobody can do anything. And when the time comes, it opens out, and then everybody will know who is the man who is going to get it and things like that. So there is no such preferential treatment for anybody. But when we come to development, definitely India wants to develop Indian industry. There is no doubt about it. So for that purpose, whenever we develop a technology, for example, the drifter, which we are now put up a tender. Tender is to transfer the technology to any industry who wants to take it from an IoT. So that also is put there, and anybody who wants to develop it in India could take it, and they could develop it and then market it internationally. Our intention is that the industry should develop it in India and market it internationally, because the cost of production and all those things, even for a multinational company, maybe if you are if they are having a sort of facility in India, I am sure that they will be able to reduce the cost of production at least I don't know, I mean 30-40% it can be reduced. So that is our intention. So many industries could come and start in India, and I have seen also that many industries are really doing it. For example, it's AUPD which we did, that industry is really good. They are doing well, and we are motivating them to compete in the international market. For example, I will tell you the Boeing parts, as I heard, Boeing many parts are being made in India. So I mean the level of technology is there, but only thing is that maybe that integration, system integration and things like that, they are not, the industries is not good, or they only first see that how many numbers I will get in 1 year. I mean maybe yes.
Well, let me ask a follow-on then. So San Diego has the largest, what we call blue tech cluster, maritime technology cluster in the United States. Is there a comparable cluster, so concentration of blue technology companies in India?
There are such areas where there is something called only export processing zone or something like that, where they get lot of tax benefits in that region. Whatever they produce there has to be only exported. There are some regions, but I don't think it will be comparable with the United States. But definitely some such concepts are there in India, maybe on a smaller scale. Yes. Yes, see, I would just say that in India, some of these collaborations, in fact, one of the other aims of my visit to here and Woodsole is to find out how to have a collaboration with our institute and here. Compared to what it was about 10 years back, it is not very easy. Earlier 10 years back, as the director of the institute, I could directly sign an MOU without any permission from my higher-ups. But now, maybe I don't know what is the reason, the government has put a lot of restrictions in that. It requires the clearance from the cabinet. It's a slightly higher level body, and that requires, that will be a process. It's not an impossible thing, but I want to do it. I want to do it with Woodsole and Scripps. That is my intention. So we will take it up. But it's slightly a difficult process, but only thing is that we really want to push it and go ahead. Now we are almost through with a similar thing with Jamstack in Japan, but of course it's almost slightly more than in a year after we started the program, process. So something similar may happen here also, but really we want to do that. Yes.
Is that institution wide when you go through that process for collaborations, or is it project to project based? And you have to go all the way through cabinet?
No, the collaboration we would first try to do it in certain areas. For example, what we think in whatever I explained here, maybe ocean observations is one of the areas where with we can work with scripts. Already there is an existing collaboration. Like you may know that the ship Roger Revel was in Chennai last week. I visited the ship also. So there is existing collaboration. So if we want to do anything, it could be only a project to project basis. But the MOU first, if we have it on a somewhat a broader perspective, then doing it on a project to project basis would be much easier. Yes.
Hi. Answers to my questions may have been already answered in the slides that I made. I apologize. I was wondering whether India has tried and explored deeper regions of Indian Ocean or Bay of Bengal for larger oil resources, and if yes, have they found anything other than already existing KG basin? And the second question is, so they have already found, is there any way that, or is there any process and phase that they want to see handled from companies not belonging to, India, basically, like unlike they have done with KG basin, which they have got handled generally from RIL, I guess. So
this aspect doesn't come under our purview, because this is being done by the Oil and Natural Gas Commission. You are aware of ONGC. ONGC is the agency to do that, and we have not worked in any of these areas. We are only working in, for example, oil and gas is something which is a routine thing which is happening. Our institute, we don't do things which others do. We are something like a R&D sort of thing. So we are not into this hydrocarbons at all. If you see, we are actually doing on gas hydrates. If you see, KG basin has got signatures. I don't know whether you were here at the time, that bottom BSR, bottom seismic reflectometer readings are there, and we are going to use this device to core samples and see how much of quantity is there. And once it comes, taking out gas hydrates is another big proposition, which is again not, I don't think anywhere in the world, except I think in Canada and some portion in some part in Russia, they have done something, but not in the deep sea. So that's a big question. But coming to the oil and gas, I don't think I will be able to answer your question, because that is not coming in my purview, and I don't want to tell anything out of some general knowledge which I too read like you from the newspapers or from the website and things like that.
Doctor, if I can ask the final question, I think it's one everyone's thinking about. Are you looking for the Malaysian airline?
Yes, we got some requests from them. They wanted to check all our acoustic, any like what we are talking about, the acoustic arrays which are there. They asked whether we have got any signatures from somewhere where we have put, but we have put only in the Indian coast. So we couldn't find anything on that. So we have informed them that we have not got any signatures from any of these. But that's really a $1 million issue, which I think all of us connected with the oceans are really breaking our head. We don't know exactly what happened, so that's a major issue. Thank you very much.